All right, so Friday we talked briefly about, we kind of went through GeoGebra and showed GeoGebra is actually doing basically all the algebra for us to recognize the patterns that exist when we have a 90-degree, 180-degree, or 270-degree rotation. And those patterns are defined up there. If I start with an x comma y as my pre-image, then my image, all you have to do is flip-flop those 2 points or 2 coordinates and negate the x value, negate the first one, and that gets you your image. Okay. Now I personally think, and this is something that I've struggled with students in the past, trying to get them to focus and understand what's going on here, is that this location and that location, they're x's. Okay, does that make sense? Even though one of them is being called a negative y, okay, it is in relationship to tell you what you do with that coordinate to get that coordinate. Does that make sense? Okay. So I think it's maybe a little bit better to rewrite these as like A comma B. I think we've done some of this. Okay. Where this is still add more room here. This is still an x value. That is still an x value. That's a y, and that is a y. Okay. However, the way they are related to one another is that this x value right here, that x value right there, is the opposite of that y value. And this y value right here is the same as that x value. Does that kind of make sense? Okay. Where if you use x and y to do that, it gets confusing a little bit for some people. Okay. Whenever I deal with anything that basically takes a set of coordinates and transforms them, changes them a little bit, I'll use like a and b or m and n or something like that, so I don't confuse myself with x's and y's and all that kind of stuff. Okay? Knowing that the structure of ordered pairs, the first coordinate of every ordered pair is an x, and the second one is always a y. So x and a y. And we went through that pattern to recognize that with 180-degree rotation, 180-degree rotation, that the ordered pair kind of stayed static. Okay, you didn't flip-flop anything. You just ended up negating both coordinates. Okay, and then the 271, you flip-flop them again, and then you negated the y coordinate. Okay, so that's what we refer to as rotations, or the rules for rotations. Now, we can do other rotations. We can do, a 45-degree rotation. We can do a 30-degree rotation. We can do a 12-degree rotation. Whatever degree you want to rotate, you can do that. It's just a lot more complex to do those. So usually, especially in this course, we're just going to do those multiples of 90. Okay. Now, when we talk about a rotation, we say 90 degrees and 180 degrees or 270 degrees, and we don't put any tag words on that. We don't say what direction we're going to rotate. The assumption is that we're always going to rotate counterclockwise. Okay? So rotating counterclockwise, so kind of the first movement from your preimage would be kind of an up and to the left movement. Does that make sense? Okay. If we want to move the other direction, we'll say that we want to move clockwise. Okay, so we'll say do a 90-degree rotation clockwise, or do a 270-degree rotation clockwise. Okay, and the reason we can do that, I don't know if with you guys if we said this or not. I think it warrants discussion. Regardless, talking about it a couple times makes it stick a little bit better. If I have that circle right there, okay, and rotations are circular motion. Okay, we're taking a point, whatever that point might be. Let's say I'm taking that point right there, P prime, and I want to rotate it 90 degrees. Well, if I say rotate 90 degrees, the assumption is we're going to go counterclockwise. So I'm going to move on this circumference 90 degrees, okay? Meaning, and we haven't talked about this with circles yet, but basically meaning that that angle right there is a 90-degree angle. would you guys agree that I could get to the same spot by going this direction? Okay. Well, if I go that direction, how many degrees do you think I would have rotated that direction? 270 degrees. Okay. So a rotation of 90 degrees counterclockwise equates to a rotation of 270 degrees clockwise. Does that kind of make sense to everybody? Okay. So, and that's the thing with circular motion. You really always have those two options. Okay. Okay. So when we do some rotation questions, they might specify a direction. Okay. When they specify a direction, we got to pay attention to that. Okay. Because we can't then just directly apply the rules that we've talked about. Okay. Our rules. Okay. So I'm going to make a column here that says counter. These are counterclockwise rules. Okay. And these rules are exactly what we have defined them already to be. So rotation 90 degrees of A comma B becomes the opposite of B comma A. A rotation of 180 degrees of A comma B becomes negative A comma negative B, and a rotation of 270 degrees of an ordered pair AB is going to become B comma negative A. That is exactly what the previous slide said to us. Okay, but those are counterclockwise rotations. Okay, they are going to ask you occasionally to rotate clockwise. Okay, so a 90-degree rotation counterclockwise. So a 90 degrees. So let's take this point right here. Let's just say it's a point that's on the x-axis, and we rotate it 90 degrees. Would you guys agree? So counterclockwise, would you agree that's going to go right there? How many degrees would you go that direction to get to the same point? 270, right? That's why I chose a point on the x-axis, because that's easy to see it. That's 90. That's 90, 90, 90, right? So 90 times 3 would be 270. So a 90-degree counterclockwise is exactly the same. So same as a rotation of 270 degrees clockwise. So I'll put just CW. Okay. A rotation 180 degrees. Think about this. If I rotate a point here, let's just say it's on the x-axis again. I rotate that 180 degrees counterclockwise. How many degrees do I need to rotate clockwise? Same 180, right? Okay. So a 180-degree rotation really doesn't matter whether you go clockwise or counterclockwise. Okay. So I'm going to just write same as rotation 180 degrees clockwise again. And then this would be, just using our logic here, 270 degrees counterclockwise would be the same as what clockwise? 90. Okay. Now here's the thing. They're going to ask you questions. They're going to ask you questions that state rotate this point, and the course exam will do this for the mere fact that they want you to apply the rule wrong. But they're going to ask you to rotate probably clockwise. Okay, and they want somebody to say, okay, maybe they say rotate 90 degrees clockwise, and they want you to instantly use your if A comma B exists in my pre-image, then negative B comma A should be in my image. They want you to use that, and you would incorrectly do it. Does that make sense? Okay. So when you see the word clockwise, you need to relate it. You need to change it to what its rotation would be counterclockwise. Okay. So every time they give me that right there, I'm never going to deal with that. I'm going to change that. Say, well, that's, if I go 90 degrees clockwise, that's the same thing as 270 degrees counterclockwise, and we now have a rule that allows us to change our ordered pairs pretty easily if I'm going counterclockwise. Does that make sense? Okay. There are rules that you can learn from moving clockwise. It's just the convention is easier to convert clockwise into counterclockwise and then apply the clockwise rule. Okay? Is that okay? All right, so let's do an example of this. Do a kind of an easier example here, using this picture. And we're not going to go through all of these. We can go through maybe 2 of them. But it says rotate around the origin. Now, it does not say which direction, correct? So what is the assumption? Right, you're going to go counterclockwise, right? So this thing here, if you think about it, we're going to rotate around the origin, okay? This image is going to rotate that way, okay? Now, if I'm going to rotate 90 degrees, so I've got the rule here. So let's look at some points here. This point is called A, as, what's that, 2, 1. Let me get a different marker here. All right, so A is located at 2, 1. If I call this point here B, it's at 6, 1. C is at 6, 3. And D is at 2, 3. Okay. Now, if I want to rotate 90 degrees counterclockwise, I'm going to apply this rule to every one of those ordered pairs. Okay? So if I look at A is going to turn into what? Negative 1, 2. So negative 1, 2 should go there. And now I have A prime. Okay? B should go to negative 1, 6. There's B prime. C is going to go to negative 3, 6. So there's C prime. And then D should go to negative 3, 2, right? And there's D prime. Now, obviously, you would want to connect that and make the shape, whatever. Okay. But what I want to prove to you is that you have the ability to check this to make sure you've done things correctly. Okay. And the rotation always comes from the origin right now, right? So I'm going to take B. Take that point B. And you can do it. You do this with any point. I'm just going to just arbitrarily choose B. In that segment right there, in that segment to B prime. So B to the origin and B prime to the origin. If I've done a 90-degree rotation, that angle right there should be what? 90 degrees. Okay? How can I algebraically, if I've got a bunch of things that are points, and I've got the names of the location of those points, the coordinates of them, what can I do to verify that those lines are indeed perpendicular? Let's clean it up a little bit. Let's go to I'm not sure what's going on with my computer, why it's so slow right now, but all right, so we had the point, what was it, 6, 1. Okay, so that point right there. Just gonna do this. All right, so we had a point 6, 1, and we want to rotate it 90 degrees. So it became negative 1, 6, right? So plot that point. So what I was showing you with those black lines that I drew, and I was getting kind of messy because we had all the points on there that we were rotating, but we should say that that's a 90-degree angle, right? What characteristic can you determine with knowing that point's ordered pair and that point's ordered pair? What can you do to verify, to confirm, to make sure that this is a right angle here? You can do slope, okay? The slope of this, rise over run, right? Okay. Rise of 1, run of 6. So that's 1 over 6. That's the slope. Okay. Slope here is rise of -6 in a run of 1, right? What's the relationship between those two slopes? What do those 3 letters stand for? Opposite sign reciprocals. Okay? And that should validate when we do, it's only going to validate it for 90-degree and 270-degree rotations, but that should be some algebra that we've learned, some geometry that we learned that can be kind of your check, be your tool to make sure you're doing this correctly. Okay? I use that as a procedure if I'm not sure what I'm doing. Okay, I get to the end of the course exam and I'm not confident in what I've done is going to work, or if I'm not confident in my memorization of that rule, if I have A comma B, it becomes negative B comma A. I should be able to do that and decipher whether I've done things correctly or not. And I should have time on that test to do that if I need to. Okay. So we should be able to, like I said, go back to, we just did it for 1 point, but we should be able to do the same thing with A and A prime, D and D prime, C and C prime, and make that conclusion. Is that all right, everybody? Okay. If I did, just coming down here to 270, let's just take A, which is at 2 comma 1, and B, which was at 6 comma 1. Let's just instead of rotating the whole thing, let's just rotate that segment. Okay. So we're going to rotate that segment. All I've got to do, okay, so A was at 2, 1, so A prime is going to go to, so if I had 2, 1 here, then you flip-flop them, right? Comes 1, 2, and then I've got to negate it. So A prime is at 1 comma negative 2. 1 comma negative 2 would be there. So there's A and A prime. And then B prime. Okay, so B, I always like to write my stuff above my rule, my specific values above my rule. So it started with 6, 1. So it says that Y value should come first, so 1. The X value should come second, and it should be negated. So 1, negative 6. So I'll ref B prime, 2, 4, 6. And now we've rotated this segment 90 degrees. Sorry, 270 degrees, right? 270 degrees. So think about this. If I connect A to A prime, going back to what we did a moment ago with GeoGebra, if I look at that set of line segments, does it look like A has rotated around the origin 270 degrees? And I can verify that because if these two things are perpendicular again, if they have opposite sign reciprocal slopes, shouldn't that be a right angle? And if that's a right angle, then we know that this here is 270 because 360 minus 90 is 270, right? Okay. So when you guys are rotating 270 or rotating 90, they're linked together. Okay, those two rotations are to understand one helps you understand the other. Is that okay with everybody? Okay, now let's do an approach here that is a little bit more difficult. Okay, and this is what you saw towards the end. If you've done that assignment, this is what you did towards the end of that assignment. Okay, Um, Pretty sure my computer just crashed. Okay. All right, so the first thing we got to talk about is what a coordinate system is. Okay, we've been dealing with the XY axis a lot, the XY plane, the XY your coordinate system, but it's not the only coordinate system. So, talk about a couple others. We call it the Cartesian plane because it's named after Rene Descartes, the guy who invented it. Okay, so what I need you to understand is that every coordinate system is a human invention. We have the desire to be able to kind of overlay. You think about like the coordinate system being kind of like a transparency. We overlay it on top of something, and now we can relate positions. Does that make sense to everybody? Okay. So, a coordinate system exists. And you think about that overlay, the transparency idea. It exists everywhere. Okay. And we can use it to kind of understand relationships between locations. And for the most part, we've been dealing with this one here. Okay. Like I said, it's Cartesian plane. A lot of times we refer to it as a rectangular system. Rectangular because if I want to move from that point to that point, I do it in right angle motions, and I've got those options. Isn't that rectangular movement? Does that kind of make sense? Okay. So that is an invention. Okay. A human invention to kind of understand space, whether it be two-dimensional or three-dimensional space. This is our, so every point there is x comma y. You know that, okay? This is another kind of invention, okay? This is allowing us to determine three-dimensional space. So every point in there has another dimension, another component. So we use the z-axis to do that, okay? And this is even another one. This is one that probably you're not familiar with, okay? This is referred to as a polar. You don't have to write any of this stuff down. This is a polar coordinate system, okay? And every location in there is r comma theta, or r represents the radius of one of these particular circles, and theta represents the angle that's necessary to get to maybe that position from there, okay? So maybe that's like 270, or sorry, 45 degrees or something like that. Does that kind of make sense? Okay. They're all human inventions. Okay. For us to understand something, you guys have all dealt with something like this before. If I get rid of all this stuff. Ohio. And you've seen something like this, where we call this 1, 2, 3, 4, 5. We call this maybe A, B, C, D, and E. We go down to F, and I put a point right there. Maybe I'm talking about Chillicothe, Ohio, and I'm trying to figure out where it is. I go to the index of the atlas, and I go to the C's. It's going to say Chillicothe somewhere. It'll tell me what page that's on. So I go, maybe it's on page 39 of my maps or my atlas. I go to page 39, but it's also supposed to say it's like P period 39, but then it will say something to the effect of maybe E3 or something like that. Does that make sense? So then I find E, find this row E, I find the column 3, and Chillicothe is in that vicinity, right? Does that make sense? Okay. That's a way, that's a human invention, it's a coordinate system, okay, using letters and numbers for us to find positions, okay? So that being said, we can alter this. Can I write this as, could I have written this as my A's B, C, D, E, and these as my numbers. Does that make sense? Okay. Could I have called these X, Y, Z, M, N, O, and use these as like, maybe use red, blue, yellow, use different colors maybe? Does that kind of make sense? Okay. It's just an invention for us to be able to create a technique to locate things. So when we talk about doing a rotation, we're going to do an activity here that actually brings in what we call a pseudo origin. Okay? You guys know what the prefix pseudo means? Maybe if you see it written. You know what that means? Yeah. Pseudo means fake. Pseudo means not real. Pseudo means kind of maybe artificial. Does that kind of make sense? Okay. So if I have like a pseudo illness, I have an illness that's not really there. Does that make sense? Okay. So when we use that word, so pseudo, pseudo origin, pseudo axes, that kind of thing. They're artificial. They're not the real ones, the traditional true ones. Okay. When I want to rotate around a point that is not the origin, this is how we do it. We locate the center that they're asking us to rotate around. And what we do at that location is we're gonna make that new point our origin, our fake or pseudo origin. Okay. Once we do that, we're going to rename our coordinates based off of that fake origin. So we're going to go back to that being the fake, that being 0, 0, and we'll rename all the points in our problem based off that. Okay. So what that does then is now it's going to allow us to rotate around an origin. It's going to allow us to use our 3 rules of rotation that we know. Okay. We'll rotate. We'll apply the rule. We'll get an ordered pair that is based off of that fake origin. And then at the end, when we have our order pair, we have our image location, we will always name it or provide its coordinates off of the true origin. So then basically we've got to undo that set of fake axes that we put in. Okay? So those steps, kind of roughly discussed there, are going to be what we walk ourselves through in this next example. I think as you're doing these, especially in homework, maybe on the test or quiz, you can see those. It's a very, very good idea to use different colors. Okay? Use a pen and a pencil. Use a pen and a marker or something like that. It's going to allow you to just organize things a little better. This procedure is exactly the same thing we'll do for dilations. Okay, so learning it once here today, and then we'll just connect the concept with dilations. So here's the idea. We're going to take a point. Let's say we take the point. I apologize for this thing being slow and weird today. All right. So I want to take the point located at, let's just say 8. Let's go 8, 2. And now instead of rotating around the origin, I want to rotate around the point 3, 1. Okay? And I want to see what that's going to provide me. What is that point going to look like? So if I do that, I'm just going to quickly ask Judge so we got an idea what our answer is going to look like. So we'll take that, rotate it around that, and I'm going to tell it to go 90 degrees. And we're going to go counterclockwise. So see if we'll end up with 2, 6. Okay, so see if we can mimic 2, 6. All right. So this is how you do it. First thing, this is your point of rotation. So you're going to put in your set of fake axes. You see it says new axes, new x-axis, new y-axis. Those are your pseudo axes. Making that point A now your pseudo origin. Okay. All right, so I'm going to do everything here in red. that is not based off of the true axes, the true origin. Okay, so everything written in blue is based off of that origin right there, right? Okay, well, I am now calling A my new 0, 0. So what would you call P if it was based off of this point here being 0, 0? How many units to the right do you have to go? 5. And then how many units up would you have to go? 1. Okay? Now, the reason we have to do that is because now we can apply the rule. The rule said 90 degrees based off the origin, right? Okay, it was never based off, our rule was never based off of any other point other than the origin. And it was A comma B becomes negative B comma A, right? So can I take 5, 1 as AB and now make it negative 1, 5? Does that make sense, everybody? So negative 1, 5, that, remember, that ordered pair came from this ordered pair, which was linked to this origin here, right? So when I plot negative 1, 5, it is off of this pseudo origin. So negative 1, so I go left 1, and then up 5. 1, 2, 3, 4, 5. And I get that point right there. Now, I'll call that P prime, okay? But it is, we just called it negative 1, 5, right? Off of this fake set of axes. The question, though, was asked in regard, and whenever I do locations, it's always asked about the traditional true origin. So once I get this point negative 1, 5, which just kind of proving to you maybe, if I plot negative 1, 5 here, oh, not negative, do it this way. Okay, so plot that point there off of this origin 0, 0. Would you guys agree that come on, there you go. 1 and 2, come on. Would you agree that the angle between those two segments looks like 90 degrees? Okay, so we have effectively rotated this thing 90 degrees around this point, okay? We just now have to redefine it, rename it off of the traditional origin. So we get rid of these, and now what would be this point P prime based off of 0, 0? It'd be 2, 6. So P prime is actually 2, 6. Okay? Now, here's the thing, and I'm kind of running out of time to do more. I'd like to do at least one more example, but I think we're running out of time. But we should be able to do that with relative ease when the numbers are small. When I say between a negative 10 and a positive 10 on both axes, you should be able to draw a picture and do that kind of thing. Okay? But what if I gave you a number like an ordered pair, that blue P up there? What if I said it was like 811, comma 2,000? Do you want to count out that far on the x-axis and the y-axis? It's a weird pain in the butt, right? Okay, it's not feasible, it's not logistical to do that. So we should have an approach that allows us to kind of figure those ordered pairs out without having to draw a picture. And here's the idea. We should be able to take a couple of these examples that we've done by hand and recognize how there's a relationship between this point 8.2 and this point 3.1 and the naming of that as 5.1. What can I do to 8, or I guess what is the relationship that you could do with that point and that point to get 5.1? Subtract them, don't you? Okay, so what I'm going to do, I'm going to call this this here as the x value of point P, and this is the y value of point P. I'm going to call this the x value of our rotation, comma, the y value of our rotation. So this point Okay, this red P should be found by being able to take the x value of your point minus the x value of your rotation. So that's going to allow you to rename the ordered pair. And then my y value would be yp minus y of your rotation. Okay, so that should allow me, no matter what this ordered pair is here, and no matter what this ordered pair is here that I'm rotating around, if I conduct this algebra here, I should name this in regards to its location off of the pseudo origin. Okay, this is going to so this provides the point that you apply your rotation rule to. Okay, so that's going to provide the point that you apply your rotation rule to. That is then you apply the rule, and it's going to give you this point up here, P prime, right? Okay. Now to undo this, okay, because P prime is going to be basically flip-flopping these and negating this one. It's not going to be named off of the traditional 0, 0. So how do I put that, this was 2, 6, right? That's what our final answer was. How does that 2, 6 and this 3, 1, how do they relate to this negative 1, 5? If I take this negative 1, 5 and I add that 3, do I get 2? If I take this 5, okay, and I add that 1, do I get this 6? Okay, so P prime, okay, let's call this, just so I can, to rename, so I write to rename P prime off of the true origin, okay? If I call this the x of P prime, and I call this y of P prime, okay, you're going to basically take x of P prime and add to it the x of your rotation, and then you'll take y of P prime and add to it the y of your rotation. Okay, so when I'm rotating around a point, those are the consistent, constant algebra ideas and concepts that are relating this process. They allow this structure of this process to occur. Essentially, you're going to remove out the point of rotation. Okay, so remove it from 8, 2. Then you apply your rule of rotation, and then you're going to put back in that point 3, 1 to your final answer. Does that make sense, everybody? So what that allows us to do is do one real quick here. Let's say that, and this is going to be messy, but it is what it is. Let's say I have the point, let's call it P. Let's say it is located at 220, 310. Nobody would ever want to count out that much, okay? Let's say that we're going to do a rotation, so I'll use R for this point. Let's rotate it around 30, 40. So we can do some easy, I think, subtraction there. What would P prime look like? Okay. So the first thing we do is take P, okay, take this point P, and you're going to rewrite it off of your rotation. So we do that x value, and you remove out the 30, right? So it'd give you 190. You're going to take this y value, remove out the 40. So it's going to give you, what, 270? Okay. Now you're going to apply your rotation. So we apply a rotation to that. Let's just do a 90-degree rotation. So if I do a 90-degree rotation, that is going to give me the point 270, comma negative 190, right? Okay. So this would be P prime. That's my final position. That's my image's position based off of 30/40 being actually 0/0. So now what do I need to do with that? Add that 30 back in, so it gives me 300. Add that 40 back in, so it gives me negative 150, right? And let's see if we have that. So let me real quick just write this stuff down because I think I'm going to have to clear it out. Maybe. Come on. Tell you what, you guys go to lunch. I will finish this video just to confirm that it does provide the same, or the correct point. There's an assignment in Math Excel due tomorrow. It was the one that I signed on Friday, so it's still open. Have a great rest of the day. Thank you. Okay, so I got this thing working again. Let's see if we can explain this. I think I misspoke in class is that once we applied the rotation, I did this. But if you look at what I did, I started with, this was an A and B, and now this became B comma negative A. That's a 270-degree rotation. I think I said 90 in class. I had to go back and re-listen to the video, but 270-degree rotation. If we were to plot these points then, so right now I plotted 220, 310. I plotted our 30/40 as our rotation, and then P prime, which would be our image after we do the rotation. And you see then that the angle here from there to there to there is 270 degrees. So we effectively did 270-degree rotation. Or if you want to look at it this way, it's saying we did a 90-degree rotation clockwise. It's the same. So that structure, that process that I defined here with you of being able to take your X values and your Y values of your pre-image, okay, and subtract then the X and Y values of your center of rotation to get a point that you can then apply a rule to, and then taking that point that you applied the rule to and then add back in over here, add back in then that center of rotation's coordinates is the effective way of rotating things with very, very, very large coordinates, okay? And it's also an effective way of saying, well, what if I want to rotate, a shape for more than just a point or a segment? If I just got a couple points, it's not that difficult to do what we just did. But if I'm rotating, just say a quadrilateral, I don't want to do that 4 times, or a hexagon, I want to do it 6 times. If I can develop kind of a systematic way of setting up my work with these points and those little formulas I showed you, you should be able to rotate that thing pretty quickly and get your ordered pairs. Hopefully that helps, makes a little bit of sense to us. We'll continue working on this next couple days.